Well, friend, let's solve one problem based on what we learned during the analysis of the resultant. So, in this case, friends, there is a particle here A, and this particle is subjected to various forces 5 Newton, 10 Newton, 9 Newton, and 8 Newton. And some angles have been shown 130 degree and 60 degree. We have to find out the resultant of all these forces in magnitude as well as direction. So let's proceed. What we will do is that this 10 Newton is here. We will try to find out the angle made by this 10 Newton at point A to the horizontal acute angle. So for that we have to draw one dotted line, say, and you can easily make out that this angle is nothing but 180. From here to here it is 180 minus 130. So 180 degree minus 130 degree, the answer comes out to be 50 degree. Similarly, this angle is 90, total angle is 90 minus 60 degree, that is 30 degree. I have computed this angle because we will be requiring this angle again and again. Now what we will do is that we will take this 10 Newton force and resolve it horizontally and vertically. This is 10 Newton force and the angle made here is 50 degree. As I have explained to you in the earlier classes, to resolve this force you need to know its starting point, which is this, and then you have to drop two lines, vertical and horizontal. From the end point you have to drop two lines, horizontal and vertical, and this intercepted portion, this is your x component or horizontal component, which is tan cos of 50 degree, and from here to here this is tan sine of 50 degree. We have seen this earlier. Now let us take 9 Newton force and resolve it. This is that 9 Newton force. The angle made by the force with the horizontal is 30 degree. Let us, from the start point, let us draw two lines, vertical and horizontal, and you should know that 30 degree is the acute angle made with the horizontal. To find the component you have to drop two lines. This is your horizontal component, this is your vertical component. All these two components, they direct away from this point. This is of course now 9 cos of 30 degree, and this component is 9 sine of 30 degree. So friends, now we are in a position to find out sigma h. Now resolving the forces horizontally and adding, we get sigma h equal to, now how to find sigma h? Look here friends, look at the original sketch. There are two inclined forces 10 and 9 which have been taken away and they have been resolved. However, I did not take away 5 Newton and 8 Newton, so I will have to concentrate on all the horizontal forces. First is 5 Newton from this, which is going towards left, so it should have negative sign. So negative 5. Then friends, we have tan cos 45. See, there is no horizontal force here, but there is a horizontal force here, but this horizontal component is going towards right, so plus tan cos of 50 degree. Similarly, here we have a horizontal component 9 cos 30 going towards the right. So since it is going towards the right, it should carry positive sign, plus 9 cos of 30 degree. There is no other horizontal force. So this is one, this is another, and this is the last one. So we have written this equation. Anyway friends, we will calculate this value later. Let us go for sigma v. Also, summation of sigma v is equal to sum of all the forces. Sigma v is equal to C. Look here at this sketch, there is one force here 8 Newton which is going down, so it will carry negative sign. Let me show it here, minus 8. Similarly, there is a force here which is going up. See, in this case there is only one vertical force which is 8 Newton going down. So after that you have to come to this, there is only one force which is going up in this case, which is tan sine 50. So let me write here plus tan sine 50 degree. And then there is yet another force here which is going down, which is 9 sine 30. Since it is going down, minus sign, minus 9 sine 30 degree. Well friends, moving further, sigma h, after calculating, we get value of this as minus 0.778 Newton. And further, we get the value of sigma v after doing calculations as minus 4.839 Newton. So the resultant will be now resultant R is equal to under root sigma h squared plus sigma v squared. You should always take these quantities into bracket. So this is equal to sigma h is minus 0.778 bracket square. It should be taken into bracket without fail, plus sigma v is minus 4.839 square, and after doing calculations we get the resultant as 4.501 Newton. Moving further, the angle, that is the angle made by the resultant with the positive x-axis, theta, is given by tan inverse of sigma v upon sigma h. This is equal to tan inverse of sigma v is minus 4.839 divided by sigma h is minus 0.778. Using calculator, we get the answer of this as 80.86 degrees. So this is how you can find out the resultant in magnitudes. So 4.501 Newton is the magnitude of the resultant, and the angle made by the resultant or the direction of the resultant theta is 80.86.